Welcome to this session. In this session, we are going to solve this problem, which is testing on application of Cauchy integral formula. So it's to evaluate the integral of 4z squared plus 16z plus 14 divided by z cubed plus 6z squared plus 11z plus 6. And the integration is with respect to z along the curve, which is a circle of radius 2.5 centered at the origin. So to solve this, the first thing will be to decompose this denominator as a product of linear terms so that we can have the structure of integral formulas for Cauchy. Now, z cubed plus 6z squared plus 11z plus 6. These are cubic expressions. So for cubic expressions, we need to factorize by trying to get the factors of this constant term to see which factors, when you replace into this polynomial, you get 0. So factors of 6 have plus or minus 1, plus or minus 2, plus or minus 3. So assuming I replace -1 in this equation, I'll have -1 cubed plus 6 -1 squared plus 11 -1 plus 6. So -1 plus 6 minus 11 plus 6. And when you add all these 4 terms, the answer will be 0, which tells us that z equals to -1. -1 is a 0 of this polynomial, which is the same thing as saying z plus 1 is a factor of z cubed plus 6z squared plus 11z plus 6. So we use long division now to get the other factor. So we say z plus 1 divided by z cubed plus 6z squared plus 11z plus 6. So z times z squared is z power 3. Z squared times 1 is z squared minus z cubed minus z cubed is 0. 6z squared minus z squared is 5z squared. Then I bring 11z, I bring 6. Now, what I need to multiply by z to get 5z squared is plus 5z. So 5z times this will give me 5z squared. 5z times 1 is 5z. Then I still subtract. 5z squared minus 5z squared is 0. 11z minus 5z is 6z. And then plus 6, I bring this 6. What I need to multiply by z to get 6z is 6. So I write here plus 6. So I'll have 6 times z is 6z. And then plus 6 times 1 is 6. So I get 0 here. So it means that then z plus 1, if I multiply by z squared plus 5z plus 6, I get z cubed plus 6z squared plus 11z plus 6. So I need to also to factorize this. This one I use just factorization of quadratic. Product is 6, sum is 5. So numbers will be 2 and 3. So therefore z squared plus 5z plus 6 can be written as z plus 3z plus 2z plus 6. When I pair, z into z plus 3 plus 2 into z plus 3. So I'll get z plus 2 and then z plus 3. So that this cubic polynomial z cubed plus 6z squared plus 11z plus 6 will be z plus 1, this factor here, and the factor of this one is z plus 2, z plus 3. So therefore now we can rewrite our function. It's like we have the integral along C. The numerator was 4z squared plus 16z plus 14, and then z cubed plus 6z squared plus 11z plus 6. So this can be written as integral. So the z, so we have the z here. So 4z squared plus 16z plus 14, z plus 1, z plus 2, z plus 3. So this is what we have. So we relate to the general f of z, z plus a, z minus a, z minus a. So when I say 1 over 2 pi I equals to f of a. So this is the Cauchy integral formula for evaluating a value of a function at the point z equals to a. So if we relate this to this structure here, so which is the same thing as saying the integral of f of z is 2 pi I f at a. So f of z from this question is 4z squared plus 16z plus 14. Now we need now to have each of these terms to be just a fraction. So we decompose this one into partial fractions. So 1 over z plus 1, z plus 2, z plus 3 is the same as a over z plus 1 plus b into z plus 1 plus 2 plus c z plus 3. So LCM is a product of all these denominators. So this denominator goes here into z plus 2, z plus 3, plus this will be b into z plus 1, z plus 3, and then plus this will be c into z plus 1, z plus 2. So it tells us that 1 numerator should be the same as a into z plus 2, z plus 3, plus b into z plus 1, z plus 3 plus c into z plus 1, z plus 2. Now, there are many ways of decomposing into partial fractions. So one of the ways now, let me say, if I fix z to minus 1, then I'll have 1 equals to a minus 1 plus 2 is 1, minus 1 plus 3 is 2. You tell me that 1 equals to 2a, so therefore a equals to a half. And when I set z to minus 2, so this term will be 0, this term will be 0, so I'll have 1 equals to b into minus 2 plus 1 is minus 1, minus 2 plus 3 is positive 1. So this means that 1 equals to minus b. So it tells me that b equals to negative 1. And then when I set z equals to minus 3, so I'll have 1 equals to, this will be 0, this will be 0, so I'll have minus 3 plus 1 is minus 2, so I have c into minus 2, then minus 3 plus 2 is minus 1. So this means I'll have 1 equals to 2c, so it tells me that c equals to a half. So that my integral of f of z dz over z plus 1, z plus 2, z plus 3 will be the same as integral along c. So f of z, now z plus 1, but then I have 2 dz. B was negative 1, so I'll have negative integral along c f of z over z plus 2 dz, and then c was this a half, so it's the same thing as saying plus integral along c of f of z dz, and then 2 into z plus 3. What is making me to write this one is because I had 1 over z, so f of z over z plus 1, z plus 2, z plus 3. After decomposing into partial fractions, I have f of z into a over z plus 1 plus b over z plus 2 plus c over z plus 3. So that now, because I've already found my a, so this is the same thing as saying f of z into a is a half. So a half over this one is what I have 1 over 2 into z plus 1. B was minus 1, so I have minus 1 over z plus 2. And c was a half, so it's 1 over 2 into z plus 3. Now, when you multiply every term by f of x, so that's why I have this one, and then you supply the integration sign. So this is what made me to write this integration equation here. So therefore now let's start now. So this is like integral 1, this is integral 2, this is integral 3. So let's start by 1. So integral 1, where we have integral f of z over 2 into z plus 1 dz. You see, this is the same thing as now. If this is a half, so I simply have integral along C. So remember this, like I have 1 over 2. It's like f of z over 2. So if I have to factor out, then it's like having a half should be factored out. So I have f of z into z plus 1 and then dz. And remember that from what we have said here, from the statement, so we have integral along C, provided that the point A is within C or on C, integral of f of z over z minus a dz equals to 2 pi I f of a. So this, we can write it as a half integral along C of f of z over z plus 1. This can be written as z minus 1, so that now we have that negative sign. So z minus 1 dz will be given by, so to remove this half here, so remember integral C f of z, z minus a dz equals to 2 pi I f of a. So this part alone, without the half, is what will give me 2 pi I, then f of minus 1. So it means that then now, if I have a half, then I'll be multiplying that answer by a half. So that's really what it means. So I'll have now a half times 2 pi I, then the value of the function, remember f of z from the equation, our f of z is given by 4z squared plus 16z plus 14. So we now 4z squared, so the z, you put -1 plus 16z -1 and then plus 14. This will be pi I into, so 4 minus 16 plus 14, that will give you 2. And this will be now 2 pi I. That is I1. I2 is the integral f of z over z plus 2 along C. Remember, C is a circle of radius 2.5. And so here A is -2. So if you try to draw a circle, 0, 1, 2, 3, -1, -2, say -3. So a circle of radius 2.5 is a circle this kind. So the point -2, as we see here, is within that circle. So which means that then we can apply that formula. So dz, you can write it as integral along C of f of z over z minus 2. So that is the formula z minus a comes out clearly. Dz equals to 2 pi I f at -2. So we'll have 2 pi I. The value of the function is 4z squared, so 4 minus 2 squared plus 16z, so 16 minus 2 plus 14. So that will be 2 pi I minus 2 squared is 4. 4 by 4, 16. So 16 minus 32 plus 14, that is -2. So -2, and then, so this will give us minus 4 pi I. So that's what we have. So just to confirm the value of b, so b, when you replace z for -2, so -2, okay, that's fine. So 2 pi I f of -2, so -4, 16, 16 minus 32 plus 14 and -2. So that will give us -4 pi I so that now for the last one, I3 will give us integral f of z dz over z plus 3 along C. But remember, the circle is of radius 2.5. So this minus 2.5, if this is 0, then this is 2.5. So here means z equals to -3. So the point -3 is outside the circle. So which means that then this integral will just be 0. So I'll have the total integral now. So I1 from this one here. So I1, I2 is given by 2 pi I, I3 is 0, and then this one here is giving us -4 pi I. So that gives us I equals to I1 plus I2 plus I3. So it should be 2 pi I plus minus 4 pi I plus 0 give us 6 pi I, because this will be plus now.